Hello, in this tutorial I'll teach you how to replicate TCP protocols. So the idea of this tutorial is so you can understand how you can replicate in code the TCP protocols. So how you can connect two different endpoints. This means the client and the server. So the idea is to give you here basis codes, like some examples, so you can understand how you can connect to different endpoints, and then you can start working from there. So you can create your own protocol, so you can transfer data between these two endpoints. So you have our library, all this code that we're gonna be presenting in this tutorial. You can access this code in our GitHub repo in this link here. Also, I'll put this link in our YouTube notes, so you can just click here and go directly to that repo. So the idea of this tutorial is to teach you how you can connect to different endpoints based in TCP sockets. To do that, we're going to use the ServerSocket class in the server sides and the socket class in the client sides, where basically we're going to transfer some data through some different classes like the BufferedReader, OutputWriter, InputStream, OutputStream, DataInputStream, DataOutputStream, ObjectInput and ObjectOutputStream. So a bunch of different classes that are going to teach you how you can use these classes to transfer different type of data to the server, from the client to the server. So to do that, I've created a bunch of examples based in this simple idea, which is basically client reads the user inputs in our terminal and then sends that specific user input, a specific message to the server. Then the server reads that message and sends back that message in HTML format to the client. The client reads that response, that's HTML, and just prints this information on the terminal. Basically, this is like very simple scenario. So to do that, I create here a bunch of examples. So the first example is the simple get server client, where basically is the implementation of this idea, where basically we're going to read from the console, from the terminal, the user input, and then we are sending through HTTP headers. We are creating a socket to the server, and we are sending that message, that user input, through the headers, so the server can read that headers and create the HTML inside and sends back that HTML to the client. In here, this is something very similar, but instead of sending the message through the headers, we are sending here in the body payloads. So for each individual user input, we are creating a new socket to the server. This means that this is like a simulation of the HTTP 1.1, the version 1.1, where for every request we are creating a socket, which means that for every request we're doing the TCP handshake to the server. Then in the third example is a little bit different, where basically we are replicating the HTTP 2.0, where basically we are reusing the same socket for the different requests. So we are not creating a different socket for each individual request. No, for all the requests to that server, we are reusing the same socket. So we are only doing the TCP handshake once. And then we have these other examples, the string protocol, where basically in here is like it's not a replication, but you have the basic logic of the gRPC protocol, where basically through the header we are sending an action and a specific payload, and the server will read this information and it will execute inside that specific method, which is the action, based in that specific message, that specific payload that receives. This is basically done in through strings, through the headers. Like sockets, we are just passing headers. Then in this example is a little bit different, is more similar with the gRPC protocol, where basically we are sending serialized objects, and we are transferring these objects through binary, in a binary form, where basically then the server, it will read that serialized object, it will convert that to an object, and it will execute a specific method inside of that object, automatically passing the corresponding payload that the server receives also, and then sends back to the client the corresponding response. In this example here is something similar, but this is not. In here we are executing a specific method, passing a specific payload. In here basically it's just teaching you how you can just transfer objects between client and server to client. This is very simple. Basically we are creating an object, a specific object on the client side, and we are transferring that object on the server side. So the server will read that object, and you can then execute execute specific methods of that object, and then you can send the response back to the client, or send the object itself again or another object to the client, so the client can read. So basically this is what teach you how you can do that. And for last but not least, what we are doing here is basically very similar with this. The difference between these two is that in here we are serializing the entire object. In here, instead of serializing the entire object, we are only passing some specific properties from the client to the server of that object, just passing some specific properties on, and we are transferring that properties on a binary form also. And then from the server side we are reading that properties, we are creating the object, the same object that we had on the client, we are creating the same object on the server side based on that properties, and then then we can execute whatever the methods that we wish, and then we can send back the corresponding response to the client. So that's basically what we are doing here. So we have different examples here just to explain how you can create different type of connections between two endpoints, how you can send different type of data between them. So basically the idea of this tutorial is to make you comfortable working with these two endpoints. So below here basically is like the code to execute each individual examples. So then you can, when you download this repo to your computer, you can just execute these commands and replicate what we'll do in this tutorial. So you can have the basis codes from your site, so then you can start creating your own protocols. So this is a very simple examples. So we are not putting here security certificates. With the idea of this tutorial is not be focused on that. The idea of this tutorial is so you can understand how you can create your own protocols on a very easy way. Of course, that's if you don't try to replicate the existing protocols, because the existing protocols has a lot of different things, as I was saying, certificates, securities, have a lot of different issues already take care. So don't try to replicate, otherwise maybe you are open a bottleneck, or you are open some hacking port in your server to be hacked. So you don't want to do that. This is specific so you can understand how you can create your own protocols. So if you want in the future, you can create your own things. So let's start. So first of all, let's open the first example, which is the simple get server, which is this one here, and let's open the correspondent files. So the client and the server. Okay, so in the client, what we are doing here, we are basically creating a class client, very simple, with some static final properties. And then in the main, what we are doing, we are basically reading, we are creating a reader from the console, so it can read the sentence that the user writes in the terminal, and then we are putting that specific sentence in a variable called sentence. If the user writes exit, automatically this will get out from the program, and this will be on a while true, so which means that every time that the user press enters, automatically it will return again in here. Then for each sentence, what we are doing, we are creating a socket, and we are connecting that socket to the host and the port that we define in here, which is the localhost port 8080 with a timeout of 60 seconds. And then we are creating a writer of that socket, so then we can send data to that specific socket, to that specific server, to this specific address that we put here, the localhost 8080. So in here, what we are doing, we are writing to this buffer these specific messages here. So we are simulating the HTTP GET protocol 1.1, where basically in here we are putting some headers where we are passing the sentence, the user input, on a header called X message. and then we are flushing. When we do the flush, it means that the client, it will really transfer all this data to the server, and then we are creating request sent. Then the server will parse this information and will send back a response. This response is read in here in this code. Basically in here what we are doing, we are creating a reader on the socket, where in here when we do reader.line, this means that the code in here will get blocked until we get something from the server side. And in here basically what we are doing is we are reading the specific line. When we get the server done string, it stops, so we are stopping here, and then we are printing the specific response. And then in here we are just closing the writer and the reader. Automatically, we don't need to close the socket, because the socket will be closed automatically because it's inside of this try. And then we do the while true, all of these again. So don't forget that when we do console.read line, also in here the code will be blocked until the user writes something. So this is from the client. From the server side, something very similar, very simple, where we are creating a class server, some static final properties. In here we have the main, where we are creating a thread pool, which will receive maximum 10 threads at a time, and it will execute that 10 threads at the same time. Where basically what we are doing here is creating a socket in the port 8080. So basically we are creating when you run this in the server, it will open this port here and it will be ready to receive client connections. So for each client connection that receives, it will create the specific sockets and will pass that socket to this client handler, which is a class that we created in here. So this is a blocking code also, which is until a client connects to the server, this will be blocked. So when the client connects to the server, then it will put that specific socket in this variable and will pass this variable to this client handler. Then this client handler here, this class, what we're gonna do basically, it is implement of a runnable, and basically which means that we need to implement the run methods, where basically in here it will create a reader buffer to read the specific data that the client transferred, where in here we are reading the specific lines. When that line is client done, which is the last part, when is the client done, basically we are getting out from this while. Until then we are always reading new lines. And then we are printing what we receive, and then we are creating a writer buffer, so we can send back the response to the client. And in here we are simulating a response from the server to the client, saying HTTP 1.1, the content type, and then we are creating here a HTML where we are passing the correspondent message, where basically is simply the request that we receive. And then we are putting here server done, so the client knows that when he gets server done, he can get out from this loop. So, and then these threads will be done, which means that the request that we receive in here, that thread, it will be done. Okay, so we can just start this, just run this. So to run this, first let's compile all the files from all the examples that we have here. So we'll just compile this, and then let's just start first the server, and then let's start the client. So in the clients, as you can see in here, I'll write something here, I'll press enter, automatically the client will create this part here, and it will print request sent, which is this one here. And then it will, from the server side basically, it will say client connected, and it will read the specific payloads, the specific data that receives from the client, and it will print the correspondent requests. As you can see here, request, and it will print what the client sent, which was this one. As you can see, it is correct with the X message AAA, which was the input of the user. And then it will send back the response, which is this one, to the client, and the client, it will read that specific response until server done, and then it will end. So as you can see here, it will, so the client, and it will write requests receive, response receive, as you can see here, and it will print what it received from the server, which is this one. As you can see, it is exactly the same, which is correct. Your message, so your message, and then it will print what it received, which was this one, exactly the same than this one on the server side. So this is basically a very simple example how you can put both client and server talking with each other. So let's get out, exit, we do exit, the client disconnects, and here we just do Ctrl+C so we can get out from this program. Okay, so now let's go to the next example, which is the post. Let's open the client, let's open the server. So in here is very similar also. Class, properties, the main, the console of reader, a read line, putting this on a sentence, and then creating a socket for each user input, and then connecting that socket to the server, and then creating a writer to send back that information. So the information gets sent when we do the writer.flush. And then in here we are creating the corresponding post requests, where basically we are putting the length, and then we are putting the specific payload from, and then in here we are doing the reader to read the correspondent response. The same thing then in the previous clients, and then in here we are closing the writer and the reader, and automatically the socket, it will be closed also because it's inside of a try. So very similar with the previous example. From the server side is something very is similar. Class server, static final properties, the main with the thread pools, the client handler class, and then inside of the run methods, client connected, we call the reader of that socket, so it can read the data transferred from the client. We put this on a request builder, so string or string builder, and then in here, when we are doing here, we are reading the content length, so then we can parse the specific payload based in the content length. So in here, what we are doing, we are reading all the headers that the client sends, but when it gets here, we stop. Basically in here we stop, and then based in the content length, we are reading the sentence, the payload that the client sends. So as we can see here, we are putting, then we are reading the next payload, the next data into the body string. And then it's simply here we are just printing the request and then the body, and then here we are creating a response based in HTML, where in here we are not passing the request as we did in the previous example, we are passing the body, as you can see here. The same thing. So then the client can read that specific response and then prints each individual line. The same thing than the previous one. So let's just execute this example. So always first the server, and then the client. So again, I put some user input here, and automatically the request was sent. The client received that specific connection. This was what the client sends, this information here, the content length, with the correspondent body, as you can see here, and then send back the response sent, as in here. It sends the response send, it sends this, and the client, it reads that specific response received, and this is what the client, the server, in this case the server, sends. The content length, so this is only the body, but the body here is not this body, the body here is this user input, the body here is this HTML. That's why you can see that the content length, it is bigger. Your message is, and in here we are just putting the body. So it is correct. So if I put here something else, it creates a new socket. As you can see here, request sends, client connects, so new sockets. So we are posting this, so the length is 18, the body is this one, and then response sends, which was this response in here. As you can see, this is working fine. Okay. So let's close these ones and let's go to the next example. So the next example is HTTP 2.0. So in these two, this was HTTP 1.1. So for each request, we're creating each individual socket, and then we were killing that socket for when the request was finished. In here is different. In here we will reuse the same socket for multiple different requests. So that's what we're gonna do. So let's open here the client and the server, where in here basically it's very similar with the previous example. So all of these classes, all of these examples has the same structure, so you can understand this easier. So the client class, the class clients, static properties, the main that creates in here the sockets, the writes and the readers. It will be initialized before. So then we have here the console reader, the buffer reader, so you can read the user input, the same thing, but in here we are creating a socket connection to the server, and then we are creating the correspondence writers and readers, and only after I do the while true. So you can read multiple user inputs based on the console, but for all the user inputs, it will reuse the same sockets, writers and readers. So it will not create new ones as it was happening before in the previous examples. So if we go to this method here, basically exactly the same thing than the previous one. We are creating a socket to the post localhost, the port 8080, with the corresponding timeout of, in this case, is 2 minutes. So let's just scroll up, and then in here we do the while true. We read the line on the console, so this block, so only when the user clicks enter, that's when the user inputs be on this sentence string. And then if the user press exit, it will get out from this from this tool, and automatically the system to request the server to close the specific connection. I'll explain this in a few minutes. Then when the user puts something different than exit, basically what we're gonna do, we'll send the request to the server, and then it will read the response from the server. So this, to send the request to the server, is something very similar as we did with the post requests, where basically we are simulating here a post HTTP. This is not 1.1, but it is more 2.0 because we are reusing the same sockets. But basically in here is we are putting the length of the sentence, and then we are sending the sentence as the body. Okay, so if we scroll up, we were in here, so this is when we send this request to the server, and in here is when we read the response from the server. Exactly very similar as in the previous examples, where basically we are reading the specific line, and then we are parsing that specific line, we are getting the content length, and then we are getting the corresponding payload on the body, and then we are just printing that specific body. That's what basically we're doing here. Then, if there is no response from the server, why and when this can happen? So let's say that we have the client creates a socket to the server with a specific timeout, and the server has a different timeout, has a different TTL in his own the socket OS definitions, which means that the server, it will kill that socket before the client kills his socket, which means that the client, it will not know that the socket it was closed, and this can bring a problem of stalled or f-open socket connections. That's why we are doing these checks here. If there is no response, maybe this socket connection it was closed from the server, but the client it was not informed about it. So if that happens, what we're gonna do is we close quietly these sockets. We just do the socket.close. We're gonna see this method after, and then we are reconnecting again the client to the server, and automatically then we need to create the correspondence writers and readers for the new sockets, and then we need to send again the requests and read again the response. That's what we are doing here. So to close the socket quietly, basically we're just doing a socket close. If there will be an exception, we'll just ignore it. So that's why it's quietly. And then we are recreating the socket connection again. as we can see in here. Create the socket connection, then we continue the correspondent methods that we already saw. When the user, another example is when the user, which was this method here, that's the method that is missing that we didn't see yet. When the user clicks exit in the console, what we're gonna do here is, instead of closing only the socket from the client side, because then the server doesn't know that that socket, that connection was closed. So basically we need to inform the server saying, please close my socket. So that's what this function does. So basically we are sending another request to the server saying, close my connection. And when the server closes that connection, that's when then we can close in here. So we read then the response, the correspondent response, and then we can close the specific socket. We do the break of this while, and automatically then when we get out from here, we close the specific socket, as you can see in here. So this is basically a simulation of HTTP 2.0, where basically we are reusing the same connection for every request, and automatically we are reconnecting to the server when we have off, open or stale connection. So this is basically the behavior of the current browsers. From the server side, is very similar with the previous examples that I show you. So class server, the thread pools, everything, the client class, the buffer readers and writers, and then in here basically we are reading the correspondent data transfer, the correspondent data transfer from the client, the correspondent request from the client, where basically we are getting the host, we are getting the content length, we are getting if the connection is closed, that means that the keep alive it is false. That means that, so this is where when we send this request closing connection, that's what basically this is checking here, so then you can close the specific client connection. And then based on the content length is getting the body, and it shows in here then the correspondent information, the client, the request, the body, the keep alive, and then it's creating a response, putting the message in a HTML format, and is sending this HTML back to the client. If it is keep alive, if it is false, if there's a break, so then it can close the specific connections in here. As you can see, client socket closed. So basically very simple. So if you can, so let's just execute this so you can see this working. So in here basically we start the server, always the server first, then we start the client, and in here already the client, it was already connected before the user put some input, and after the user put some input it will not connect anymore, it will use this connection here. So automatically the request was sent to the server, so the server receives these clients, it receives this request, this was what we sent to the server receives it with the correspondent body, that's what we sent, and then it will create the HTML response, and it will send, based on this body, to send a new HTML response, where basically the client receives this response and it prints that specific response. So this is what the server sends. So this in here should not be 1.1, should be 2.0, but it's fine. And then it sends a correspondent body. As you can see here, HTML with the correspondent message the user input. If I put here something else, it's the client, it is the same, as you can see. The same client, it is reusing the same client, the same socket connection, and the same thing happened. So this was sent, in here was received with the correspondent body, and the response was sent, which was this response. As you can see here, this is working fine. When I do exit, automatically in here the server receives a correspondent request saying close this connection, and automatically you can see here client disconnected, and we get out from here, client is now disconnected. So currently this is working fine. So then we can move forward to the other examples, which is the string protocol, and then after we're going to see these other binaries. So let's see the string protocol. Let's review again what the string protocol does, this example. Okay, string protocol. Basically what it does is the client will send through the header, so something very similar with the previous examples, will send a specific header with a specific action, and then will send a payload which will be the message, and then the server will read the action and the message, and it will execute in the server side that specific action passing that specific payload. So that's what the string protocol does. So let's open the string protocol here, the client and the server. Let's review the client again. The clients, class clients, static final properties, main. We are creating a socket to the specific host and port, localhost 8080, and then we are putting here a string action A and the specific payload, which will be the sentence. And then we are writing to these sockets. We are sending to the server. When we do the flash, we are sending this data here, where basically we are passing the action and the correspondent message. From the server side, again, class server, the thread pools, everything the same thing than before, the client handler, and inside of the run we do the reader to read the correspondent client data, client request data, and then here if it is client done, it's break, so we get out from to read the lines. Otherwise we are getting the actions, and then we are getting the correspondent message in here. And then what we are doing here is we are printing the correspondence request, and then we do, if the action is equal to A, we are executing a specific action. If it is equal to B, we are executing other action. Otherwise we are showing this other return message, whatever. So basically we are printing, simulating a specific action, which is printing a message saying executing action A. And then the output, we are creating an output, a response, so then we can send this response to the client again. And in here we are creating that response in a HTML format. So then the client can read then that response from the server until the server is done, until we have this string here. So then we can print that specific response from the server. And then we are just closing the writers, the readers, and the correspondent sockets that we created. Very simple. So let's just start here the string protocol so you can see how this works. So basically in here we don't have the user input writing anything, so we, as you could see here, it will send, the client will send automatically the action A and with the correspondent payload. So in here it will the server send request send, which is this one here, request send. The client received these requests, which is correct, got the action A correctly, the message correctly also, and it prints this string here, which is basically the simulation saying that the action is equal to A, so it will print doing action A with the status true, which is this. So the idea is in here you could replace this by calling a specific method inside of another class. It's just an example. And then sends the response to the client, where the client receives the response, which basically receives this response here, this output message, which is action A was executed with the status, the correspondent status. As you can see here, action A was executed with the status true. If I execute this again, basically it replicates, it connects with the client again, and it basically replicates the previous action. This is exactly the same thing. So basically this is how you can basically replicate not the gRPC, but in a very simple way. There are some similarities. Basically, if you want to execute something in some other endpoint, you can use something like this, where you can pass things through the headers, or you can use the post get or the post to execute something. So something you are basically simulating in here, like a REST protocol. This is just a simple example. For the gRPC protocol. So this is like similarities with gRPC and RESTs. So more similar with gRPC, it's the binary serialized object. This protocol is more similar with gRPC, where basically in here we are creating a client where the client basically to execute a method. It will ask the server to execute a method passing a specific payload, and then the server to receive that data, so the method to execute and the specific parameters, and automatically to execute that method if it exists, and then you'll send the response to the client. So we can see this one here. So it's, let's see, it's this one here. So let's open the client and the server, where basically here it's a little bit different. So in the main, basically what we are doing here is we are calling the clients. So the client is this class here, where we are putting client call, which is this method here, where we are passing a string and an object, which string is the method of that should be executed on the server side, and then the parameters, which are the corresponding parameters to be input in the methods. And then we are printing the corresponding results, and then we are calling another method, passing different parameters and printing the corresponding results. So the call method, it returns an object. It could be a string, it could be an integer, it is an object. So in here, for each call that we do, we are creating a socket to the server, and then we are creating a specific object that I'm going to show you in a few, and then we are passing that, we are transferring that object via binary in a serialized way. So to do that, we're going to use the ObjectOutputStream and the ObjectInputStream. So the ObjectInputStream is to read the data that comes from the server. The OutputStream, it is to write something to the server, to send something to the server. So what we are doing here is to writing these new objects, where basically we are passing the method and the parameters to the server, and then we are doing flush, so automatically the client sends this information to the server. So this class here is very simple class. It's just a class to create objects, to have the method and the corresponding parameters inside. That's it, very simple. So then we are writing the objects. So this will basically serialize this object and send this in a binary form. And then we are receiving, and then the server, it will process all of this, it will create the response, and then it will return that response based in these other objects. And this other object basically is a class that just receives the results in an object and an exception if there will be an exception. Very simple. And in here basically we are doing the object in read objects, and we are putting this to this variable here, and if there is no error, then we are just returning the corresponding results, where in here this returns a string, this will return an int. So in here we are casting the things to the corresponding types, and then we are printing the corresponding results from the server side. Again, class server, static final properties, the main, the thread pool, the client sockets with the client handler, the same thing. And then inside of the run, instead of using the BufferedReader, what we are doing is we are using the ObjectInputStream and the ObjectOutputStream, the same thing. So we are doing the object in read objects, so we can get the first request, object request, where we are basically passing, from here we are getting the methods and the parameters, and then later on we'll create the RPC response. So after we get the requests, then we are comparing the methods. If it is a say hello, we are executing this method, passing the corresponding parameters, as we can see in here, request parameters, passing the correspondent, we are invoking the specific method. If the method, if will be add, then we are getting that specific method, so then we can invoke that method with the corresponding parameters. So this is basically a very simple thing. And then based on the result, that we are getting in here, we are creating a new response, a new RPC response, a new object with the corresponding error if there is any error. And then we are doing the flush, so it can send back that response to the client. The action handler basically is a class inside of here which contains two methods, the sayHello and the add. sayHello receives one parameter, the add receives two parameters. As you can see here in the clients, then the sayHello we are only passing one parameter, for the add we are passing two different parameters. So basically if we execute this, we're going to see the corresponding prints. So let's scroll down and let's execute first the server and then the client. As you can see here, client was connected because we are calling the sayHello and then the add, so two clients connected. It is correct, and then it's putting the corresponding result. Hello João and 8, which is correct. So in here, João, don't forget that when in the server we are prepending the hello, so it is correct. And for the add we are summing the two parameters, which in here we put 5 and 3, which is 8, so it is correct. So basically it's like a more equivalent simulation of the gRPC protocol, where basically we are transferring serialized objects in binary form through the network between two different endpoints, from client to server and from server to client. This is a good example of the gRPC protocol. Don't forget that this is not a replication. This is a simulation. This a replication, you need to have certificates, security, other issues handling. So we don't have that currently. So this is just so you can understand in a very high level how you can create your own protocols. Okay, so then we have these two last ones. So the binary serialized objects, where basically what we have in this example is just to teach you how to transfer objects from client to server and server to clients. That's very simple. So let's open these ones here. So this is the binary serialized object, so client and server. So for the client side, what we are doing here, basically we are just using ObjectOutputStream, ObjectInputStream, and so we can write the correspondence object. So what we are doing in this example is we are using the console. The user will put something in the console, and then we are passing that specific message that the user put inside of a class. This class here, echo class. This echo task. This echo task is very simple. Implements this other task here, remote executable, which is just extend serialize and has a method execute. And what this the echo task does is it saves the message that we are passing here. This will be the user input, and then automatically when we call the execute method, it just writes this sentence here plus the user input. That's it, very simple. So then we are putting this task here, and we are passing we'll put this task in the object out, where we are in here. Additionally, what we are doing also here is we are sending some headers also. In here we are creating a map, a hash map, where we have multiple headers, and then we are writing that through the object output stream. We are writing this object, the headers, and then we are passing this task. Also we are writing that task to the right objects. And then we are flushing, which means that we are sending two objects through the network via serialized binary form. So which means that on the client side we have also the object in and object out, and in here we get the first object. So when we do read object, object in, read object, the first object will be the map, it will be the headers, and the second object it will be the task. So this will be the first object, the map, and then the second it will be the task. And then the server, it will prepare the response. It will put that task, it will execute it we're gonna see this in a more detailed way, and then it will write the result in the object out, and it will fetch it, will send it to the client. So then the client in here can read the response, and then can show the corresponding response. So let's see the server, and then and then it will close the corresponding sockets. A socket is inside of a try in here, the socket and the corresponding console buffer also, and the corresponding streams. Okay, so let's see the server in a more careful way, in a more detailed way. So what we are doing here is this while true, we are doing a while true because the server can read if the client, after the client be connected, the client can send multiple different objects, so the server can read all that objects. So what we are doing here is, first we are reading the first object, which is the map, so we are saying read the objects, and then if this first object, if is not a map, shows an exception. In this case not shows an exception. What it's doing here is sending an error basically to the client side, so the client side can read. Since the client side reads objects, so basically we are sending here write object, we are sending a string with an error message. Then what we are doing here is then convert, if it is a map, convert that map into a map string, which will be the headers, and then print that headers. And then reads the second object, which is a task. And for this second object, the receive, if is not the type of remote executable, so don't forget that in here. So the echo task, it implements the remote executable. So what we are doing here in the server, we are checking if is not the instance of remote executable, sends the error again. Otherwise, if it is, let's cast that variable, the receive, to the real task. So then the real task we can just call the method execute, because the remote executable has the method execute. So in here we are executing this specific object, and we are showing the result, and then we are sending the result back to the client. That's where then the client reads that specific result and just prints it. So let's just execute this so you can see this working. So let's start the server, and then let's start the client. So we put some user input here, and automatically the object was sent, the server received, created the new client. You can see that receives the header, so this is the print of the hash map. So we are sending these headers here, the content type, the user agent, and the request ID. So user agent, request ID, and the content type, it is correct. So this is the print of hash map, and then it's showing the receive task. So the receive task, so we are printing the name of the class, which is protocol echo task, it is correct. And then we are executing the methods, printing the results. As you can see here, it's execute correctly. As you can see in here, echo task executed on server, and then put the user input, and then it sends the correspondent results to the client, where the client then it reads this result and just prints it, server result, and then the correspondent result coming from the server, which is this one here. Is it the same? As you can see, it is correct if the user puts other input, and then this is inside of a while true, so we can again do the same thing. So in here we did the same thing, where in here we are receiving, we send the response, this client connection is still active, so there is no client connect anymore, so it still is the same client. So what we are seeing here is we send the 111, and automatically we see here the same headers, and then the corresponding task, the corresponding execute result, and then the result received in the client side, which is also correct. So for last, we have the manual properties. So in this one here, I show you how you can send serialized objects, the entire serialization of an object. In here is a different approach, where instead of sending all the serialized objects, all that data, in here we are only sending specific properties of the objects via binary also, and then in the server side we are creating that objects. This is a little bit faster, but is not so much flexible. So this is more flexible, this is a little bit faster because we are transferring less data. So let's see this one here, the manual. So let's create open the client, open the server. So the clients very similar. So instead of using the objects OutputStream and InputStream, we are using the DataOutputStream and DataInputStream. So what we are doing here is basically, again, creating the console, reading the input of the console, creating the specific objects also, but then what we are doing is in here we are writing this, we are only passing the specific message to the DataOutputStream of that specific socket. So let's open this class here. What we are doing here is getting this user input and creating basically this message, put this message on a binary form based in bytes. That's what we are doing here, and writing a lot of other things before. So then we can read this from the server side, so we can identify how we can parse the message and which type of the message it is. And then so this is the method 1. The method 2 is where something different, where we send also the headers. But let's see first the method 1, and then I'll explain you the method 2. So from the server side, what we are doing here is we are using the DataInputStream and OutputStream also. So, and for the what we are doing here is we read the requests, so based in the data in. So what we are doing is first it is the magic, so we send first here the magic, then the version, then some codes, and then the length, and then the message in bytes. So first we need to read the magic to be sure that it is coming from the right client. This is like, imagine this as like a security thing. Then we are reading the version to be sure it is the same version, because you can have different type of versions, which means that on the server side can be parsed in different ways. Then we are reading the first bytes, which is here. So we have two different types of sending messages, the opcode echo and the opcode echo with headers, so 1 and 2. So then we read that bytes here, the opcode, and then we read the length, and then we read the corresponding payload, the user input, and then we put all of these in a class called request, which is this class request is basically just a very simple class that just saves the opcode and the payload. Why? So then the request, I can check the opcode. If it is opcode without headers, I do this. If it is with headers, do something else. So if it is a simple echo, as the method 1, as we were showing in here, then what we do simply is we get the payload, which is a user input, and we create in the server side a new class. So we are not passing the serialize, we're just passing the user input, the message. And in here we know that, okay, if it is this specific type, we create this class with this parameter. And then we just call the execute, we show it, and then we send that correspondent response back to the client, where basically we are showing the message and something very similar with the previous thing. So we have the result, we are converting the result to bytes, and we are sending write byte 1, the length, and the corresponding payload, the corresponding response. So then the client side, we can read the response in here. The response we put is a byte, we read the first byte, we'll read the length, and then we read the payload, the response, and we return that response, where in here we are just printing it. On the method 2, we are sending some headers, we are creating an hash map with some headers, where in here we are calling a different method, where in here we are passing that headers, that hash map, plus the message. In here we don't have headers, in here we have headers. So what we are doing in here, basically, in here we are creating a new payload, where that payload contains, we are converting that hash map into a string, splitted key value, splitted with these delimiters, and then key value, key value, key value, key value, and at the end, first we pass the corresponding size, and then we do key value, and then at the end we put the payload of the message, and then we convert these to bytes, and only after we do the magic, the version, the opcode, the length, and the UTF, and the corresponding bytes, and we do the flush to send this to the server. From the server side, then we read these requests, the same thing. So we do the magic, the version, the opcode, the length, and the UTF. That's what this does, exactly than before. This is the same method that I already explained. And then we are checking, we check the opcode. If the opcode is with headers, then we know that we need to split the payload with this delimiter. And we know that the first one, it is the size of the hash map. So then we can do the loop, and we know that we do the loop where we are incrementing the index with 2. So we know that 0 is the key, the 1, the index plus 1, it is the value. And then we are putting plus 2, so then in here is the same. So in here the index is the key and the other one is the value. For the last one, we know that there is the message. So then in here we can create, we print and the headers. So in here we are recreating the hash map with the headers, we print and the headers, and then in here we are recreating the echo task object, passing the corresponding message. We are executing then this message, printing it, and then we are sending back the response with the corresponding message. So then the client can reads back the response. That's it. Very simple also. So basically these different ways, instead of passing all the serialized objects, we are just passing specific properties. So let's just execute this last one. Example. So let's start always first the server and then the client. Where in here we put corresponding inputs, and automatically the server receives that specific client requests with these specific headers. Well, in this case, first it is without headers, with the specific user input. Response sends, it sends without the headers. And then, so he is not printing here the result because the result is the same. So in here we are sending, if you realize in the method 1, we are not getting the response. We could have put here the response, we didn't do it, but it's fine, it is the same thing. And then we do the second request, the method 2, we send with the headers, where in here it receives with the corresponding headers, as you can see here. And then it calls, in here it executes the echo task from the server side. As you can see here, do the print of the execute method, which is the print, which prints this, which is, let me open here echo tasks, so it prints this message here, which is correct, and then sends back the response with only the user input with the message. In here do the execute, in here only sends the message. That's when the clients do the server results, the user input, which is correct. If we do some other user input, it's the same thing. So in here we are executing the echo task without headers. In here we are executing the task with headers. Method 1, method 2. And is the correspondent results. Where in here, okay, in here is sending because, so that's why, so because I didn't put here the read response in the method 1, is getting now this A is from the method 2. So I needed to do this to be correct. I needed to do something like that. So let's kill this. And let's compile this again. And let's call both examples once again. So in here I call AAA, which is correct. When in here I put 111, now I can see that I have 111 here, but still it's showing AAA. Okay, the reason why it didn't work is because I had an error, so when the compilation worked, it didn't really compile the thing. So let's just compile this again. Let's just execute this again. Here the same thing, so we do the AAA. It is correct. When we do the 111, now as you can see, it is correct. And that's it. So basically, this is just two different examples. Or in this case multiple different examples of showing different ways of creating protocols in different ways. So passing binary data through the manual properties, or passing binary serialized objects, or executing then specific informations in the server sides, passing the headers without headers, putting posts with GET requests, with reusing socket connections, or having the code prepared to be ready for the style of open socket connections, or having for each request in each individual socket. So these are basically what my purpose was, to show you different examples that you can use, that you can according with your requirements, you can have multiple different examples, as you can see here, and you can reuse them. So the idea is you can understand how you can create your own protocols, your own TCP protocols. Again, if you want to get this code, just go to this repo here. I'll put this repo in our YouTube notes, and if you need some assistance, just let me know. Thank you very much.